It's a great pleasure today to have Daniel Slutsky talk to us about data science walkthrough.
Thank you so much.
And yes, the recording will be posted, yes. Answering question.
Yeah, thank you. Thank you so much, Elena. All recordings are posted in the Zulip stream, and most of them will be up at YouTube in a few days. And thank you, everybody, for joining. What we hope to do today is to have to walk through a few of the libraries and tools in the emerging data science stack in Clojure. Tomorrow, there will be another session that will focus on machine learning, on mostly this amazing library called CyclogeML by Carsten Behring. And today, we maybe will kind of anticipate what we have tomorrow a little bit. What we will do is have like a little bit of exploration of the data set, and we'll have some examples we can look into, but I hope we will also explore together, ask questions together, and try to maybe answer them. And I'll post the repo after this session later today. There are a few things to fix, so I didn't want to push it now, so sorry for this. And so we can all use the screen I will be sharing. And if it is okay, maybe does anybody wish to say anything about your current thoughts about the current Clojure data science stack, about what you hope to see there, about what you have experienced in it so far? And if you have any interest in certain aspects of data science, certain needs, like certain libraries or computational needs, and it would be lovely to hear what you might be interested in. We will see. Yeah. Hi.
Hi, Daniel. I think I will take the bait there. So I'm more like a traditional enterprise software developer. Recently been using Clojure I'm introducing Clojure into a new organization. This organization would like to start doing data science, right? Like hyper growth, that kind of thing. And I would like to be able to speak knowledgeably about the capabilities that Clojure offers in this space. And if it's possible, maybe even bring something to the table with that. Yeah, you're talking about things I might want to know. Is like, yeah, like myself, I don't have a machine learning or data science. I don't have a background like that. So for me, this is new. Yeah.
That helps a lot to know. Thank you. Does anybody else wish to say about your viewpoint, your interests in this session?
I'm happy to jump in.
In chat.
Oh, sorry.
Oh, I just mentioned that there is a comment in the chat here. So Daniel, maybe you can address later, but yeah, go ahead.
Yeah, I was just going to say I haven't actually used Clojure actively for a few years, but I've since transitioned from a software developer to a data scientist. I'm just kind of interested to see what's happened in the Clojure world for the last few years and learn more about, you know, I've always thought it would be a great language for doing data science in. So yeah, I was just interested to see what the developments are and get a bit of a flavor. So for me, it's very much an overview and kind of just getting a sense of what's happening.
Fantastic, thank you. Yeah, and I'll read the comment in the chat. ST writes, I would be interested what libraries to use for basic statistics like standard deviation, confidence testing, and similar. Can this be solved at the moment using external bridges to Wolfram OR? Another question, is there a point in using data frames versus regular Clojure structures? Perfect, thank you. Yeah, perfect agenda for today. Yeah, maybe I'll comment about this briefly. So basic statistics is something that can be done in Clojure without needing any bridge to the outside. And we can demonstrate that today. We will use a library called FastMath by our friend Tomasz Zulip, which is one of the nice ways to do statistics in Clojure. And also there was a workshop by Rohit Tadani, who is here today, about various statistical tools and computations in Clojure. And I think there are bridges to R and to Wolfram language, as you mentioned. Specifically, the bridge to R is useful. It has been used, but it is not production ready. It needs more care to be more robust for use in production. The bridge to Wolfram has just been revived, and we will see later today about the state of it. Probably it needs more care and more exploration, but it looks very promising. About the question of data frames versus regular Clojure structures, yes, we look into it. We look into how we work with data frames and what they mean and discuss it. Great. Any other thoughts about the agenda for today? We will begin in a few moments, but if there is any other need, it would be great to know. So maybe I'll share my screen, and we will kind of practice things by looking into some data, and hopefully that will be useful. So you see my screen. I will not see you so much, and I will. So you could just interrupt me with your voices if that is comfortable, and I'll also look sometimes in the Zulip chat. And please mute yourself while not speaking, if it is okay.
Can we make your screen bigger so we can read better? Is it small?
Absolutely, yeah.
Here.
Yeah, but it was late last night. He was also having.
Yeah. Thank you. So here it is bigger, and this is bigger.
Oh, much better. Thank you.
Yeah, thank you, thank you. So we have a certain namespace here and some data set we will be exploring. And this data set is coming from the Zulip, the Clojurian Zulip chat that we have here. And it is not the raw data. We didn't want to share the raw data in GitHub. So we kind of removed some of the information, like the messages themselves, so that we can have a data set that can be shared in GitHub. And the details about how we prepare this are here, and I will share them as well. This data was collected by our friend Sami Kallinen from the Zulip API, and yeah, and everything we'll be doing today is joint work with Sami Kallinen and Ethan Miller, who are also preparing a talk for the conference about similar topics. And the way we will be working is, you see, I have my editor here, which is Emacs, and we'll have a certain browser view using this tool called NodeSpace that some of us use. And this browser view will allow us to look into the code and some visual output. And yeah, and if you could mute yourself while not speaking, it would be good. Oh, thank you. Yeah, so I'm just checking if there are any comments. Can you share a link to your code if available? So JF, I will share the link after the session, after doing some improvements. But for now, I can share the draft that already exists, which is very partial to what we need. But let us share it. Because a few things will need some improvements before I may finalize it, but here it is. Yeah, so yeah, and you know, I hope during the session we look into the stack of libraries and comment about them. So one of the things that we have here is node space. And you see node space is this browser view that is updating whenever I'm having some interaction with my Clojure editor. And there are a few other tools like that that allow this so-called notebook experience where we can tell the story of our code in some visual way. And a few of them are very much similar in the idea of being able to stay in the editor and have some browser view. So a few of the other relevant tools are OZ, the famous OZ, which is much more polished and exists for some time already, and we'll have a workshop about it, and also Clerk that will have a talk at the conference, and also some emerging new tool called Goldly that we'll hear more about in the near future. And so all these tools are for literate programming, and there are more of these, and we'll discuss them in other workshops. And any comments about that? We will not focus on this experience today, but we'll just kind of experience it. Any thoughts about this? Yeah, please interrupt me if you have anything. Another thing we will look into is working with data. So you see in our setup here, we have some data set that we are reading from a CSV file. And the way we are reading it is using the tablecloth library. And tablecloth also had a dedicated workshop. And it is a data frame library, which means it allows us to think in tables, right? To work with tables of data. And you see, we just created this data set. And if we print this, then we have this nice browser view of the data with all the different columns. And what are these columns? Each line here is a new message by somebody who wrote a message in the Zulip chat. And you see, you have the stream and the topic and all kind of information, timestamp and such, and also some columns that were added by some sentiment analysis that Sami Kaldinen did, and maybe we'll discuss this more later. Some analysis of the content of the message, which is not here, like we omitted the content in this data set. And you see, we're just reading the data set using tablecloth. We'll not dive in too much into the API, but you can just read a table structure from a CSV file, and it is contained in a very much efficient way, and maybe we'll discuss this in a moment. Any comments about this so far? Yeah, so it is kind of related to the comment that we had in a chat about these two different alternatives in Clojure of working with data, where one allows us to use plain Clojure data structures like sequences and vectors and maps, and another allows us to think in tables that are potentially stored in a more efficient way, efficient both in memory and in performance for various operations. And yeah, that is part of the point here, that if we have a column of numbers, that these numbers would be better, would rather be stored in a contiguous way in memory that takes our knowledge of the type of number into account, because that is more efficient both in memory and in time performance. And there was a whole workshop about that, about this infrastructure called dtype next, which is a way of working with arrays of numbers and other types in Clojure. And this tablecloth library is using dtype next behind the scenes to store things efficiently. So that is one point about working with tables. That can be efficient. Another point is that the ergonomics of it might be nice. It might be a nice experience while processing data to think about the data, as a table. And I hope we'll experience that when we are processing this. Really a matter of taste, of course. Any thoughts about this? Yeah, so you see, we will not look into all the details here, but one thing we might be interested in this data set, and maybe we'll do a little today and more tomorrow, is trying to predict whether a certain message in the Zulip chat will get a quick response. Like, what should I do? Should I write an informative title? Should I do it in a certain time of day? What would make my message get a quick response of another person? And so that is kind of a prediction problem, and we will try to explore that. And we have some data preparations here that were done mostly by Sami Kallinen and Ethan Miller in their research, and we will look into a bit of the data processing that is taking place here. And I'm just checking for comments in the chat. Oh, great, thank you. So thanks for this comment, JF. So JF is mentioning two different libraries for working with tables. One is tablecloth, and another is TechML dataset, or TechV3 dataset, as it is now called. What is the relationship? So tablecloth is a wrapper of TechML dataset, and it is a wrapper that tries to make the API consistent and user-friendly and intuitive. Most of the tablecloth operations will use a TechML dataset behind the scenes, but tablecloth adds a few other options. For example, certain very interesting group by operation and other kinds of nice surprises to data processing of tables. So in a sense, it makes sense to use both. Some of the things which are happening in tablecloth are not as efficient as the TechML dataset, but mostly they are just fine and fast. And in terms of functionality, you may find some things which are available in one of these libraries and not on the other. My practice would be to use tablecloth whenever I can, and TechML dataset whenever I need something that is just not there. Just because the tablecloth API is so consistent and nice. Does it make sense? Or any thoughts about this? Any comments? Great. So see, maybe we'll not look into all the data processing that we have here, but maybe we'll try to get a taste of it, just a little bit of what is happening here. So you see, we have these prepared messages, and I'll use the node space view that allows me to see the last evaluated value. And so when I, for example, evaluate these prepared messages, I'll have this table. That is our basic data set after some data preparation. So you see each row is a message, right? And what are we doing now here? So the idea is that we want to look into the messages under a certain topic as a time series, right? So for example, we have the topic of this meeting. So if I click this topic, now I'm focusing on this topic of this meeting. So we can look into this as a time series. For example, I just wrote a message here, and JF wrote another message, and we could consider the message by JF as a response to my message. Not always that is true, but at least that means that the topic remained active. And we want to look into that as a time series. So it makes sense to look into things in the context of a topic. So we are taking our data set and we are grouping by stream and topic, because there is this hierarchy of streams and topics. So what happens when we do that? Let us try to look, right? So we have our prepared messages, right? Let us see how they look. So that is these are the prepared messages. What happens when we group by a stream and topic? We get a new data set, which is a grouped data set. And we see now every row is a group of messages, right? So you see this column gives the context of this row, which is in this case the topic hello in the stream data science. And this column contains whole data sets. So here inside we have a whole data set which contains all the messages, all the 66 messages in this hello topic, right? So we grouped things together, and now we can look into each of these as a time series of its own and do some time series analysis over it if we wish to, right? So if we wish to kind of understand a little more, then yeah, maybe since we mentioned it, let's mention that. We said we mentioned the quick data set here, and let us require another namespace that will help us see a little more. It is a namespace of this TechML dataset library, which is indeed the infrastructure behind tablecloth. And there is this nice printing namespace there. And if we use that namespace, we can change how tables are printed. So we can say, for example, that the print policy would be what they call a REPL. And oh, now I'm stuck because it is printing too much. Now that is a trouble, right? But yeah, my editor is stuck, right? So I'll stop this. And oh, something is wrong, right? Oh, these are all errors, right? So yeah, maybe just take the head just to be sure. Oh. Yeah, still challenging. Yeah, it is a big data set, so not all modes of printing would be useful. Yeah, I guess I'll skip this. But what I hoped to show was that there is another way to look into a group data set. And maybe just to give you an idea of it, let us look into some toy data set so that we can look into it. I think I'll just refresh the browser just in case. And yeah, let us do some small example, okay? Because that was too heavy at the moment. So I'll create a very small data set. Right, so that's a data set. Oh, I think something is wrong. I think
Daniel,
yeah.
You imported it as print, and that seemed to be a reserved name or something. Keyword, yeah, that name.
Thank you.
Yeah.
That's
So
a good idea.
Yeah.
Maybe. Thank you. Yeah. I think I'll restart the REPL just in case, because I just don't know what is making it heavy. So no worries. Just a restart. It will take a moment. Yeah. So what I hope to do in a moment is look into this idea of group by, which is very much central to the thinking of this tablecloth library, and see how we can enjoy it. And so I'll evaluate the namespace again, just in case, and just to see that everything is fine. And then we will have like a small example of grouping operations. So right here we have a data set, and we can do, we can look into it as a data set. I'll also restart the namespace tool so that we can have the browser view, and yeah, and we can look into a data set we're creating, right? So we have a data set. So what happens when we do group by? for example, grouping by the Y column. So we get again this view that we saw earlier, right, where every group has a whole data set under the data column. And the point is that if you wish, you can print it more nicely or more in a more informative way. So at least when your data set is not so big, you can have this printing where you see the data set with all the details of each data set inside the column. But maybe at least conceptually, it helps us to understand what grouping is, right? So group by created this nested data set, right? Which is maybe printed, rendered in a bit of an awkward way, right? Any questions about this? So this grouped data set that we will usually print without these additional details like that, right? This grouped data set is a very central idea in the tablecloth library. And the nice thing about it is that these data sets, which are subsets of the original data set, they are not copies of those subsets, rather they are views of those subsets. And these views are using this dtype next technology to be very efficient about kind of giving a snapshot of some part of the data set without wasting more memory. And that allows for quite nice computations without wasting memory and without wasting too much time. So that is this idea of grouping. And now in our case, we were grouping by stream and topic, right? So we were doing that. We were grouping by stream and topic, and we got these separate data sets of messages where each one of these we want to think about as a time series, right? And then we are doing some computation. So for example, we can add columns. And what happens, right? For example, let us look into one of these computations, like what happens if we do this add column, right? So we are saying we wish to add a column, and that is the name of the column we are adding. And the column is defined in this certain way, a function that says how to compute the column. And maybe let us not dive into the details now, right? But there is a certain function that takes the data set and returns the column to be added to the data set, in a sense, right? So what happens when we do that? So did you notice any change in the browser view? Maybe you did. Now we have 17 here, not 16. So these data sets inside, they grew, they got a new column. So you see this add column operation is respecting the fact that we're working with a group data set. And that is typical to the way tablecloth works. We can work in the context of a group data set. And then we can also ungroup. And when we ungroup, we get something of the original shape again, right? All the groups were torn apart and they're all together again in one data set. But we got the new column, right? So in this way, we could compute this new column in the context of the group. And in this case, it was important because this column was doing some basic time series analysis, and time series need the context of a certain topic, right? What this column does is checking for every message whether this message is the same sender as the last, right? So this needs the context of a topic to make sense. So that is like a tiny example of the fact that tablecloth can be fun as a way of thinking about tables. I hope you experience it as possibly fun, and I hope this kind of sheds some light. But maybe we'll not do a lot of it today. There was also a very nice workshop about tablecloth by our friend May, and it is recorded. Any comments about this? Any thoughts about tablecloth or any other thing before we continue? Okay, and you see we're doing some computations here, and we have this fun namespace. Fun is for functional. This namespace is coming from this dtype next library that also had a workshop of its own. And what this fun namespace has is lots of functions for working with array-like structures. So for example, what is this fun shift function that we're using here? So fun shift allows us to shift an array-like structure. So for example, let us pass some numbers. Oh, right, I need to say how much I'm shifting. So let us say I'm shifting 1. Right, so, oh, we have the browser beyond the, right? So this shift is giving us that structure, right? So you see, we shifted things in one step and also kind of completed the missing values by some logic. And we could also shift to the other side. And this shift was useful in this time series analysis that Sami and Ethan were doing on these data. And so this functional namespace contains lots of useful functions, which are also efficient when you use efficient data structures. And the columns of tabletop tables are efficient by default, which means they're using this dtype next library underneath the tablecloth. And so, right, so we mentioned here dtype next for array processing, and it also has had a few workshops about it in the last few weeks. Another thing that is happening here is the use of a library called tablecloth time that allows for some time conversions and all kinds of operations that are useful in time series analysis. And tablecloth time is still work in progress. It is developed by Ethan Miller and our friend Siddharthan, and it is very much trying to adopt the tablecloth philosophy of making a consistent API of few functions that are useful in various situations. And here we're just using just a little bit of it in constructing these messages. You know, and that is typical to a data science situation. You have a certain data set, and then you wish to create more ways to think about the data. So typically you are adding many columns, which are some processing of the existing columns. So now usually these additional columns, or in general, your columns are mostly called features. That is a certain name of like in the machine learning jargon of columns of your data. And so now we have this data set that got many new columns, right? Like, for example, some things about the time, and also this column is kind of interesting. It looks into the future and says, what is the time to the next response? Well, a response means a message by another user on the same topic, right? Like here, I was writing this and JF was responding to me in a sense, right? So it is at least this simplistic idea of what a response means. So here, that is the number of seconds that took to get the next response on this topic, right? So this column is special in that it is looking into the future. And tomorrow, we will focus on doing some predictions of this next response time. Today, we'll maybe look a little bit into it. Any comments about this? You know, I'm trying to give a taste of a real-world data processing, data analysis session, and in this case, I'm using this existing research of Ethan and Sami that kindly allowed me to join them.
I have a small question.
Yeah.
I was wondering, would you be able to show us the content of one of the groups in the group by example earlier?
Yeah.
I saw that you get a grouping with a meta description, but if you want to look at, let's say, some of the 66 message in one group, how would you do it? Thank you.
Yeah. Yeah. So let us show a few ways to do it. So here we get the group data set again. And what we can do, for example, is to look into the data column, which just contains the groups. So when we look into the data column, you see that we can fetch the column using a keyword. Why can we do that? Right? We know in Clojure that keywords act as functions. When do keywords act as functions in Clojure? When we have maps, right? Typically when we have maps. So the keyword data over the map data 9 and ABCD 11 would give 9, right? So in this case, we see that our data set that looks like that and has a column called data, this data set is also a map, right? Let us ask, is it a map? The answer is true. Yes, a data set implements the necessary interfaces to be considered as a map. So that means if we just use the name of the column keyword, then we get, what do we get? We get the whole column. What was that column? That column contained data sets. All the groups are data sets, right? So when we do that, we just get all those data sets in the column. So let us take the first of them. And that is the first group, which is just a certain topic called hello in the stream of data science. And that's it. Is it good?
Yes, thank you.
Yeah, thank
There's
you.
also a question in chat. How does it figure out who responded to whom? And I'll let you. Yeah.
Oh, thank you. Yeah. So, you know, we don't know, right? What we are doing is some basic data analysis where we are not aspiring to understand the full semantics of a conversation. We just want to have a clue of what could be responses. And that is kind of a heuristic, right? So the idea here is that whenever somebody is writing a message or a few messages, and another person is writing a message, that other message will be considered a response. And that is not always true, of course. Right?
And that's within the same group.
Yes, thank you so much. Within the same group, which is in the Zulip hierarchy, it means a topic inside the stream. Yes, thank you so much. Right. So in this case, we always think that here, you know, Jakub was responding to RGM, even if it wasn't necessarily a response to RGM, right? That's our heuristic, which is not so clever, but might be useful when our task is to try to predict, for example, whether we can create a very active conversation that will get some activity, right? And yeah, we are not any more clever than that in this case. Right. I'll skip a little bit. We're adding more columns that are kind of useful. Now we'll talk about splitting the data, which is kind of an important topic. And but maybe there are more comments before that. Yeah, so yeah, maybe I'll stop sharing for a moment, kind of so that we can have a conversation. And so there is this idea called supervised learning, which is part of the world of machine learning. And the idea of supervised learning is that we have some data to train on, and we have some target function that we wish to learn to do better on the training data. And then later we have some test data where we should use what we have trained for. And so typically we would split our data set at least into a training and testing data. And typically it will be a little more because the practice is a little bit more complicated than that. In the training itself, there will be more splitting typically. And the question is sometimes how to take a given data set and split it into training and testing subsets in a way that would be useful for our machine learning task. And the way we split matters. And does it make sense? Or are there any questions about that or thoughts about that? So in our situation, what we hope to learn to do, we hope to learn to predict the time for a response to a message, right? And we will, as we said, we want to think about topics as time series where we have some things going on in this context of a topic and possibly in parallel going on in another topic, which is considered a different conversation, like a different email thread, or so to speak, right? So that is our context, a topic. And then how would we divide our data set that has many messages in streams and topics? How would we divide it into training and testing so that we have a useful setup for learning? Any ideas about how to do it? Any suggestions? So one core idea here would be that we wouldn't like to take one conversation and split it in a way that part of the conversation takes place in training and another one in testing, which that would just happen if we just split the data by random, if we take every message and toss a coin to decide whether it will be in training or testing, which is, you know, a common practice. So this common practice of splitting by tossing a coin, it wouldn't work in this case because we will tear apart our conversation, and then the time series is broken. The time for response, the time for the next message in the conversation wouldn't be the same in training. And maybe there is a more subtle problem here if we are mixing training and testing in the same conversation. That thing that is called leakage in machine learning, or data leakage. And the idea is that sometimes, you know, you have a certain phenomenon that is taking place in your data, and in your training, you're learning it, and you might be learning this very kind of curious phenomenon too much. And then if this very same incident is also mixed into the test set, then when testing, we will actually test on this very same incident, which is actually not testing on a different situation. It is testing on the same situation. So, for example, when we do geographical machine learning, we wouldn't like, depends on the case, but sometimes we wouldn't like to use the same neighborhood for training and testing, because then, you know, a very specific situation or a very specific neighborhood could be very powerful in your data, and then you would be training on that and then testing on that, and the same event or the same very local situation just leaked into your testing. So it wouldn't be independent testing. And that kind of leakage, to avoid it in our context, we need at least to have separate conversations on training and testing. So what is a conversation, right? How do we model a conversation? So one way to model it is a given day in a given topic, right? That is not a very clever way to model it, but that is what we do at the moment in our analysis. So maybe I'll share the screen again and see how it looks. Share screen. Right. So when we do our split, we will group by topic and date. So every given day of every given topic will be considered a separate conversation, and that is hopefully avoiding most of the relevant leakage. Might not avoid all the leakage. Still, there might be a given special incident where a few topic threads were active in a given time in a way that was kind of dependent, and maybe in this way, some of them are present in testing and some in training, but at least we try to avoid the most obvious way of leakage. And that is typical. You know, this idea of leakage is subtle. You need to think about your data in order to see if your setup makes sense in a way. And any comments about that? And maybe we look into the details here in a moment, but maybe any thoughts or questions about this idea of leakage and about the need to split to training and testing? Great. So what we are doing here is taking our messages, grouping by topic and date, and then we are doing some processing. And what are we doing? So let us ignore this strange term without grouping for a moment. What are the next steps here? So one step is to split the data by some method called holdout. So we are splitting the data by random. And then we are adding a column. And let us avoid, oh, I see a comment, sorry. And in this case, leakage, JF is saying, leakage would also occur from the time zone of data sampling versus that of the participants in some cases. Yeah, there is something kind of arbitrary. We're all using kind of the same time zone to encode all messages. And possibly, maybe what you mean, JF, and maybe you would like to use your voice to explain more. Maybe what you mean is that there is a certain, might be a certain overlap between days of a certain conversation that is taking place on 2 different days.
Yes, that's what I meant.
Absolutely. Yeah, absolutely. So what we are doing here is not so careful. There might be a leakage. There might be a conversation that goes beyond a certain day because especially because of time zone differences. Absolutely, thank you. Yeah, so maybe we let us avoid this add column, which is kind of tedious. Maybe you shouldn't bother about it. But the idea here is that splitting is a tablecloth operation, and we wouldn't like to do it inside the groups. We would like to do it between the groups. So we would like to do the splitting over the grouped data set, right? So that is why we need to say without grouping. It is a way, using this kind of threading macro, it is a way to tell tablecloth to act over the grouped data set, but not by the usual way of working inside groups. That is the typical tablecloth way, as we saw earlier. Maybe I shouldn't confuse you too much about it. I just want to show that tablecloth has the expressivity to handle different situations of how one may want to act on a grouped data set. And what you need may depend on the context. And there are a few more interesting functions related to that, and we will skip that for the moment. I think the documentation of the API in tabletop is so wonderful that it is just a nice section to read in the docs, and you will enjoy reading it. So here in this case, we did some careful grouping and ungrouping so that we could split the data set by splitting the grouped data set. So we got this result, which looks like that. Oh, isn't it printing? I have no idea why it's not printing. Now maybe I'll restart the yeah, here is the split data set, right? It has two subsets which are called train and test. That is by default the behavior of this split function. Yeah, and I'm kind of skipping the details, but I think the point here is that we have the expressivity we need to create various ways of handling these delicate situations. Now, I think what we hope to do after the break is to mostly explore the training set and maybe then create some model that can be tested over the test set. And tomorrow we'll have more of that modeling part. But maybe are there some questions or thoughts before the break? Could be nice to think if you have some ideas of how to explore the data set, and maybe we could practice it together. Otherwise, we'll just look into some columns and distributions. We'll visualize some things and find some relationships between variables. Any comments or thoughts? Great. Elena, is it a good time for a break? Is it okay if we...
Yeah, I think it's a good time for, what are we doing, 5 minutes?
Maybe 10?
10 minutes sounds good. Okay.
Yeah.
I'll stop the recording.
Yeah, hello again. So we're continuing this exploration of this data problem, which is part of this research by Sami Kaldinen and Ethan Miller. And we were talking about splitting the data for training and testing. And now there is a comment by ST in the chat. So maybe I'll read the comment. 2 thoughts. 1, if you are selecting messages randomly for the training and testing, how are you able to reproduce results? Then results will be different every time you do a training. Yeah, thank you. Let us talk about it. 2, what about selecting training and testing data differently? For example, by slicing the data into n even parts and use some parts for training, some for testing. Would that solve the leakage problem? So I didn't understand number 2 yet, but let us maybe begin by number 1. So yeah, very often when we have randomness in our workflows, it is important to make the randomness reproducible. Typically, what we use is some pseudo random generator, which is some software running that is initialized by some value that can be repeated. That is the so-called seed, and I guess that is what you're hinting at. And when we are building libraries and tools for that, we need to make sure they can allow us to specify the seed of randomness so that it can be reproduced. I don't remember about the function that we used, but maybe let us check. So I'll share the screen again. And right, so what I did was kind of not so careful splitting here. So let us look at this split. Oh, I'm not in the right namespace. Not this one. Not this one. Yeah, split. So we were using this split function of the tablecloth library. Let us jump to definition and see what it tells us. So what we typically look for is the seed. Yeah, so we have a seed. Let us try it. Yeah. And you see, yeah, that is typical to the tablecloth API of functions, that a function would usually have a few different arities allowing for different numbers of arguments. And at least one of them would usually have this map of additional options that can be provided. And here, one of these options is the seed. So let us try. And so here we are. And what we need to do is seed some number. And now let us see, let us actually try it so that we can verify. So let us take some toy data set. Or maybe just some numbers. Right, so that is our data set, these numbers. And now we can say TC split with this hold down approach. And you see, it was split by random between training and testing. So number 2 here was in training, and number 5 in training, etc. So let us try again. Right, so you were right. It is not reproducible this way, right? It is always changing. So what happens if we specify the seed? Then it is fixed, right? I do again and again and I get the same results. So yeah, that was important. Thank you so much. And
do you need to specify the seed for a specific function? What's the scope of the seed?
Yeah, it is for this function call of split. And sometimes, yeah, thank you. That is an important comment. Sometimes you may wish to have a seed not for a specific function call, but for a whole data flow that has some randomness in it. And then depending on the library you use, typically there is a way to do it. In tablecloth, I think it is typical to do it on a specific function call like sampling or splitting. They would usually have their own seed. If you wish to have more control on this, then this fast math library that we may see a little bit later, it has some control over the construction of a random number generator, when you wish to construct it, when you wish to switch it, and so you can be more in control if you wish. Now let us maybe look into the other comment. Oh, I see there is more. So yeah, so ST is explaining about number 2. With ST, I meant what you explained by special situation or same neighborhood problem. If we split the data into n parts, then both the training and testing will get input from different parts of the time series. I guess it depends on how you are splitting into parts. Maybe I'm not sure. So
I have a sense that it's by date. That's how I'm reading it. But
I see. So for example, if
yeah, so you slice it. Yeah, okay. So yes, the response is yes, exactly.
Oh, thank you. Yeah, that makes sense. So you're saying splitting might not be random, right? Thank you so much. Yes. So in time series, it is often very much a useful idea, especially if we have one time series. So we are not able to look into a certain point in time and use it for training and testing. So we wish to kind of be more sterile. And yeah, so that could be a common practice. For example, every given week would be used either for testing or for training. And those would be those slices you were mentioning. And that could be wonderful for some situations. And that is more safe in terms of the worry of leakage we were mentioning. What we hoped in our situation was that different topics of conversations wouldn't leak into one another, right? And that thought might be wrong. And in that case, what you're suggesting, taking every week, for example, for a separate as a separate slice and using it either for training or for testing, that would be safer. What are we losing if we are taking whole weeks or months? What we're losing is that the information of belonging to a certain week or month in the year could be actually useful. Maybe we wish to learn that the month of July has better response times. If we wish to learn that, then we might want to have it for both testing and training. So we need to be careful about the choice of slices. And yes, that comment was so helpful. Thank you so much for this. Any more thoughts about this before we continue? Great. So there was another comment by ST about what about statistics? Or maybe it is a good time to look a little bit into statistics. And by the way, yeah, never mind. So let us mention now fast math, which is a library by our friend Tomáš Zulip, which is huge. It has lots of math and statistics functions, which are available in the JVM from various sources, and they are collected with a nice API in fast math. And let us just like have a little taste of some of them. So maybe we add this fast math code. Just adding a few of the namespaces. Oh, maybe let's also add this one, which is sometimes useful. Oh, stats already exists. Let's see, stats. Oh, yeah, so yeah. So I'll not use an alias here, actually. Yeah. Great. So yeah, and you see there are some statistical functions in this D-type next library as well, and they are very much useful. But I guess here we could use FastMath. Yeah, also JF is suggesting to have a basic comparison of FastMath versus others, like Kixi stats. So yeah, so let us mention them. For statistics, there is FastMath, there is Kixi stats, and there is also the type next, like specifically this namespace. So what would we like to use? So maybe that would be one way to order them. So functions from dtype next are typically the fastest when you find them. That is like the stereotype, and also usually true. Dtype next tries to be very much optimized in the use of memory and time to do things. So if you find a function there, that would be a good idea to use it. And most functions there would be implementations which are tailored for this idea of an array-like structure that dtype next offers. And there was a whole workshop about it that repeated a few times this month. And fast math is a much bigger collection of functions from a few libraries, mostly Java libraries, which are very much nicely wrapped in Clojure. As everything that Tomasz is creating, it is very much nicely documented, and also just a huge collection of useful functions. Some things you will find only there. Mostly, you should expect it to be well-performing because these things are taken from Java libraries, which are taking care of performance. Typically, these are the Smile library and the Apache Commons math and stats. And so things there would be decently performing and also very diverse in their uses. Kixie-stats is a library by Henry Garner that is written in Clojure and works in the context of transducers, which is this more general sequential context that doesn't need to be something you have in memory. It could be an async stream of data that is arriving, but it could also be an array of data in memory. So Kixie-stats is, in a sense, more general in where it applies, and it has a nice collection of functions which are written in Clojure for these more general sequential situations. And here we will use fast math just a little bit for the taste of it, but these are the differences of these three wonderful collection of statistical functions by Chris and Tomasz and Henry. Is it good? Any comments about this? Maybe somebody has something to add about these statistical libraries. Great. So maybe just let us try fast math for statistics. So we have our training data, and let us look at the training data just a little bit. And oh, where am I? Here. Yeah. So so we have our split data, this split by topic and date. That is not obvious, as you mentioned, but that is our split at the moment, and that is how it looks. Oh, again, my editor is struggling for some reason, and I don't know why. Oh. Ooh, yeah, that is an older error. Is it ready now? No. Oh. I'll not try to solve it now. I'll restart the reference. Yeah, no idea what happened. Yeah. So in a moment we'll have the REPL restarted and try again. Yeah, but yeah, it is something to worry about. And yeah, by the way, in the meantime, let us talk about this practice of using def once. Def once in Clojure is a way to define something only once. So the next time this thing is evaluated, if we evaluate this block of code when this var is already defined, then it wouldn't it wouldn't be defined again. And it is sometimes a useful practice when we are exploring data to have some of our data sets defined once, and then, you know, typically we can quickly evaluate the whole namespace without having to evaluate these parts of the code again. And for example, here we define this data set that we are reading from a file. It wouldn't make sense to read the file again and again every time we are evaluating the namespace. So that is why we use that once. And another practice that we sometimes use is delay. Delay is a way of defining a thing that is not evaluating unless you dereference it. And maybe we'll talk about delay soon about this practice. But let us try some statistics. So first I'm trying to evaluate the whole namespace to see that everything is fine. I don't know why it crashed. Something today is like that. Yeah, and it is loading some of the machine learning libraries that we might use a little later. And yeah, so the REPL is ready, and we can look into this training data set. Let us restart the notebook. So we have this notebook view, and we have this training data set, right? The training data set that we defined in the split. So let's pick an interesting column and maybe look into some statistics. So for example, we could look at this next response time, which was defined by this logic that Sami and Ethan engineered in the research. So that is a column, right? So can we do some statistics? Yeah, we can look into the FastMap stats namespace, and we have this nice collection of statistical functions. So can we compute the mean, for example? Then yes, we can, right? So that is the mean, and we have the median, and we have standard deviation, as you mentioned. And so, yeah, we have a nice collection of statistical functions. Yeah, so that is one thing, like one way to compute the mean. Another way is using this Kixi library that you mentioned that we don't have in the dependencies now. Another way is to use the tech v3 data type for this functional namespace that we mentioned earlier of the type next. In this case, would allow us to compute the mean and a few other aggregation functions. And yeah, and this other namespace of tech v3 data type statistics has more, like standard deviation, for example. Or yeah, so that would be the standard deviation. And here, if we want to use FastMap, then we have standard deviation. Which is, yeah, is it the same? Yeah. Right, so a few ways to compute statistics. And we could, maybe in a moment we like to compute more. Any thoughts about that? Great, so I think it would be nice to visualize something so that we get a taste of our data. And since we had a whole workshop about the Hanami library for visualization, then maybe now we'll try something else, even though probably Hanami will be useful again in a moment. So there is this TechViz library, which is again by Chris Neuenberger, who is also the author of D-Type Next and TechML dataset. TechViz. Is it loading? I hope. Yeah. So TechViz is a nice library for data visualization, and we'll try it. Another library is Viz CLJ by Ashima Panjwani that will have a talk at the Clojure conference, and maybe we'll try it too. So let us try TechViz. Let's look into this next response time variable, which is so interesting, and try to draw a histogram, this plot that gives us an idea of the distribution of things. And so TechViz Vega has a nice collection of functions that create data visualizations of which are Vega specs of this Vega client-side library. And there is this histogram function, which is one of them, and you see it needs to get the values and label, and the values are, yeah. So the label, I guess, is just for, yeah, actually, let's see where the label is used, probably just as the type as the for the axis. Yeah, so let us call it next response time. What do we get here? Oh, so my editor is stuck because, yeah, that is the typical problem times. Yeah, I kind of aborted this because it was heavy for the editor. And let's see if this thing is, oh, I'm kind of concerned about this. Oh, yeah, about this behavior that I'm experiencing today. Sorry for this. I think just so that we don't have to cope with it, I'll restart the REPL for a moment. And in the meantime, let us kind of mention a few of the data visualization libraries. So we have TechViz that is generating different kinds of data visualizations, including Vega, but also others. And we have Hanami, which is one way to create Vega and Vega Lite plots in Clojure. Vega and Vega Lite are these common data formats for visualization, and there was a whole workshop about it. And there is Viz CLJ, which is another layer on top of Hanami. And there is also CLJ plot, which is a whole Clojure-based library that is kind of more low level and more in control of the details and very much expressive in what you can do with it, again by Tomasz. And I guess we now hope to try TechViz, and we have the REPL again running. And yeah, and let us try it. So I just want to see that it computes. So I didn't want it to print so much. So I just check this. See if it works. Yeah, so it does work. And now, as typically in this tool, we have a node space tool. We can kind of tell it the kind of visualization that we're creating. And in this case, we want a visualization of the Vega kind. And oh, I didn't restart the node space tool, so I restart it now so that we can see things. And yeah, so we see a histogram, and you see it is boring, right? What is a histogram? A histogram is this idea of having values and binning them into certain intervals and counting the values in each bin. And we see we're getting this very boring example where this leftmost bin has almost all the values and the other bins are almost empty, right? And that happens when our data is kind of concentrated on some part, but actually has some big values that are kind of taking some part of the interval. And so a logarithmic scale of the data would help here to have a bit like a different view of the axis. So we could take the logarithm, or maybe in basis 10 of all values, and maybe then let us have a different label for it. Or yeah, but actually let us keep this plot and create it for, right? So this will make it kind of oh, right. So we got a problem, right? Some values did not have a logarithm because they were either missing or 0. And so we cannot compute a logarithmic scale in each situation. In this case, I think there were some data problems that caused negative values. It is typical, you have data problems sometimes, right? But we'll not try to solve the problems now in this session. We will just filter them out, right? So what we can do is filter. Well, each value we can check, is it positive? That is my guess, that negative number, that non-positive numbers were the problem. I hope that is the correct guess, right? Yeah, so it was correct, right? And we see now the histogram of the log transformation of the next response times. That does give us some idea of how much typically it takes to get a response. And you know, in this case, these numbers, what they mean is 4 means 10 to the power 4, which is 10,000, right? And 2 means 10 to the second power, which means 100, right? So it is a logarithmic scale. And so that was a little taste of this TechViz library. And the nice thing about it is not only this coloring of data, but the fact that it can do some data processing before passing the data to be visualized in the browser. So the binning is computed in the backend in the JVM, so it can be more efficient, can handle bigger data sets, and then the data we're passing to the client is smaller. And so it is a nice way to draw a histogram. Any comments about this? Any questions?
I think there are some questions in the chat here.
Oh, thank you. So here is the chat. Not this one. I look at the other chat. Thank you. So I'm looking in the other chat, and yeah, Duncan Mortimer says, why did that work? Isn't the filtering happening after? Oh, yeah, you're right. I have no idea. So probably, yeah, I guess the reason it worked was that when we had, actually, let us check, right? Let us check what happened. Let us not guess. So what we had was those values, and maybe I'll close this window of the chat that you probably can't see. So we had those logarithm values, right? So these are the values. And let us check. Are they sometimes infinite or not a number, right? These Java JVM floating point numbers can have a few different notions of something which is not a finite number. So let us check. For example, are they not a number sometimes? So yes, 20 of them were not a number. Now, what happens after we filter? Do we still have not a numbers? So it turns out that filtering by requiring a positive number did filter out the not a numbers. Strange, I didn't know that. So it turns out that this special not a number value in Java, oh, maybe I didn't write it correctly. So sorry, double not a number. So if we compare it, if we ask if it is positive, then it is simply false. So that is why filtering works. But thank you for being suspicious. That was important. Yeah, let us see other comments. Chat. Andres is saying histogram wants positive numbers. Maybe I lost the context for this claim.
It may have been a response to the previous.
Oh, I see. Yeah, thank you. Thanks. ST is saying, do you know of any visualization library that is dynamic? By that, I mean, for example, a diagram that you can zoom into or move the time window which is displayed, measure things, for example, distance between peaks, etc. Such would complement the dynamism of the REPL notebook nicely. Great, yeah. So somehow many of us like to use this Vega and Vega Lite technology, which is kind of declarative and fits nicely with Clojure philosophy. And Vega and Vega Lite do have notions of interactivity. And I think there was some nice demonstration by our friend Tovier, Moses Ozzy in the workshop about derivatives. There was an interactive plot there. And you can define interactions. There is a nice grammar for that in Vega and Vega Lite. Not all kinds of interaction will be very fast there. Sometimes you may want something which is more performant. And there is, for example, the bokeh library, which is commonly used in Python, and it has a client side which can be used without Python. And I know there is an effort to build a Clojure backend to bokeh, so that is another promising direction. And CLJ plot that we mentioned also will also support some dynamism, I think, but maybe at the moment not so much. Another is Plotly, that also can be used from Clojure, and Plotly also has nice interactivity. And whatever data visualization library you're using, it is kind of sadly coupled with the tool you're using. And at the moment, we have those several notebook-like tools, and different tools currently support some subset of the available libraries. Eventually, hopefully, will converge to an ecosystem where everything works with everything. And if you have any specific need, that would be wonderful to create a Zulip discussion about it, so that we can kind of follow up after this session for their specific need. Yeah, so thank you so much. And let us continue a little bit. We have 15 minutes, and maybe we should leave a few minutes for kind of concluding. And so maybe we'll just explore a little more. And we'll not do machine learning today. Tomorrow we'll use the same data set for machine learning pipelines. So I have a few other visualizations here, so maybe we could get a taste of a few other things in the short time we have. Here, for example, you see, I wanted to test the relationship between different variables to our target, which is the next response time. So maybe first, before doing this elaborate thing, let us try one of them, right? So we could, for example, take our training data and group by year, and maybe order by the year, order the group data, and then we could aggregate the group data to get the median next response time. So we get an idea of, for every year, what with a typical response time. So we see, you know, 2020 had faster responses than 2019. Maybe we should order by here. Yeah. Right. So 2019 had, well, this community has been still growing, having the first steps. It seems to be slower by this very rough analysis, right? And 2020 was more active, typically, by this interpretation. So now, can we visualize it? So in this case, we'll use this VizCLJ library, which is another emerging library by Ashima Panjwani. And right, we need to say the x-axis is year. Then we can get a nice bar chart, for example. Now, what if we want to kind of not have only one number, or maybe it should be maybe a point chart would be more appropriate here. Of the response times. So what if we don't want to get just one number per year, but kind of get an idea of the distribution of values throughout the year? So we could use a box plot. That is one visual way to do that. But first, maybe let us look into a few of these bar charts for a few of the relevant variables. So here there is a nice column in the data set called keyword question mark that Ethan, I think, added in the research. And that checks about the content of the message. Did the message contain a question mark? Right? So we see that messages that did contain question marks have typically shorter response times compared to those that didn't contain a question mark, right? So maybe you should have question marks in your messages if you wish to get a response. And of course, that is a very rough interpretation here. We should be more careful. And the way to be, one way to be careful would be statistical inference. And that was, we had a nice lecture by Rohit Radani about it. Another practice for being careful in checking, verifying that a certain phenomenon holds is the practice of supervised learning. And that is what we'll do tomorrow. So here, we already saw that. So yeah, we have a few of those sentiment analysis columns that Sami added to the data set. So Sami checked for a few keywords in the data. So you see messages that had joy in them typically got shorter responses, etc. So now we can like have a variation of this and look into box plots, which are those ways to see not only one value, which is the median, but a whole distribution of values. And maybe we'll not get into the details of exactly what a box plot is, but it gives some idea about it. Yeah, maybe we should skip considering the time. I'm checking for comments. Oh, yeah. JF is asking, what is the metadata before some forms, for example, kind hiccup? Doesn't look like a full type reference or Clojure typing. Thanks. Yeah, so that is related to this tool we're using, NoteSpace. It is a way to tell NoteSpace to visualize this thing as hiccup. Actually, we did it in two ways here, so that was maybe not needed. So you see, oh, maybe or maybe this plot. Oh, something is broken now. Oh. Yeah. Oh, this works. And yeah, this one works. So here I was using two ways to tell NoteSpace about the kind of thing to be visualized. And if I don't tell it about the kind, probably I shouldn't have used these two ways. So now you see, I didn't tell NodeSpace the kind of thing I was visualizing, so NodeSpace just treated it as a data structure. But if I tell it, yeah, this thing should be considered as Hiccup, which is this Clojure way of writing HTML, then it should render it as HTML, which is the result of Hiccup conversion. And it is a little bit of a trouble that we need a way to tell our tool how to visualize things. And it is a trouble because now we have a few interesting tools and they have different conventions for these. And here, there is an attempt to create a library which is called Kindly, which is a way to specifying the kinds of things. And it is work in progress. And what we mostly need is certain dialogue of different tools and libraries in the ecosystem so that we could converge to good conventions for these things. Here we see the very much opinionated way of this tool NodeSpace that we use. Yeah, so that is this comment. Let's see if there are any other comments in the other chat. No. So maybe we'll continue just a little more. Or actually there are 5 minutes, so maybe it is time for discussion. And what we are anticipating is having some machine learning pipelines, which is what we'll do tomorrow. Yeah, so should we discuss a few things, see if there are any comments? Oh, I see a comment. ST is writing, is it possible to have NodeSpace take inputs, for example, forms or buttons? No, at the moment it is not supported. And a few of the tools that does support that, let us mention, another comment. Oh, sorry, this was this comment. So maybe I'll share the screen again so that we have those notes. So we mentioned a few of these literate programming tools. Another tool that we didn't mention because maybe it is a bit different is Site. Because Site is a whole new experience of browser-based interaction. So these are a few of these tools, and I think at least Clerk and Goldly and Site are allowing for some creation of maybe also Oz of some client-side components that allow you to have some control of input. And NodeSpace is mostly focusing at the moment on just listening to user interactions in the REPL and reflecting that in a browser view. And probably NodeSpace will converge to using one of these other libraries as a front end. And then it will be interesting to explore how these things could be combined. See another comment? No. Yeah, and we have this multiplicity of tools, which is the current topic for lots of thought and hopes for the future. And that is why I am happy we have a few workshops about different tools and also a few talks in the coming conference. And let us see if we have some thoughts or comments or maybe wishes for future sessions that will explore more of some of these topics.
Hi, Daniel. Not a question, really, just a note of appreciation. Thank you for your time. Hey, you've opened my eyes to a lot of things here. Definitely very valuable, and a much appreciation from my side.
That is so kind. Thank you. Thank you for your time. Yeah, great. So maybe after the recording, if you wish, a few of us can stay and chat a little bit. And later today, I will push things to the repo and share the repo in the Zulip stream. And yeah, and I hope to see you tomorrow in the machine learning workshop.
Yeah, thank you very much. Yeah, it was really great.